So now we are going to look at actually another video, and in this video we are going to solve another question. So this question says which of the following options represent the overall order and molecularity of hydrolysis of acetal acetate, giving us uh, CH3COO, CH2, CH5, which is methyl acetate hydrolyzed in the presence of water molecule. So now, actually, we need to understand order of the reaction and the molecularity before we start solving the question. And it is very, very important. So generally, in writing order of the reaction, we need to know how to actually write the rate expression. So generally, let's say we have a reaction where you have A plus B to produce C and D. So how are we now going to write this expression? So to write this expression, or to write the rate expression here, is simple. So we usually say rates is equal to Q. We have Q, which is called rate constant. And then we now write A and B. So usually the key here is called rate constant. Actually, it's a law. We call it rate law. We call it rate law. And the rate law state that the rate of the reaction is directly proportional to the concentration of the reactant. It's directly proportional to the concentration of the reactant. So it is just actually showing the relationship between the rates and the concentration of the reactant. So therefore, in this case, the rate law is directly proportional to the concentration of the reactant. So you have nothing to do with the concentration of the product. And in some cases, this rate law, you see that in some cases, you see that some powers here, maybe power A here and power B. So what this power B indicates, they indicate actually the order of the reaction. They indicate the order of the reaction. It means here you have A power A. So the A here indicates A is a first order, and sorry, A is A order and B is a B order. So to get the overall order of the reaction, you are now going to say A plus B. So when you take now A plus B, so this A plus B will give you an idea of what the overall order of the reaction is going to be. So now, this question is now asking us what is the order of the reaction. So it means that in this case, to get the order of this reaction, it's now going to, because this is the reaction. So therefore, we are now going to have something like this. We are now going to say rates. The rate is going to be the K, which is rate constant, open bracket, the concentration of CH3, COO, C2, H5, then we now close it, and then times, of course, the concentration of water. So, but in this case, we are not considering water because water, it serves as a medium. The water here is served as a medium for the reaction to take place. So we are not considering water. So since we are not considering water, it means that even in the rate expression, we are going to remove it entirely. We are going to remove it entirely because water is served as a medium. So you consider this one. So it means that the reaction is first order reaction because this one is completely neglected. That is water because water is served as a medium. And then the second one is molecularity. So what is molecularity? The molecularity indicates the number of molecules or the number of reactants that are participated during the course of the reaction. So the number of molecules that are involved during the course of the reaction is what you call molecularity. Like for example, in this case, how many molecules or how many reactants do we have? We have two reactants. We have this and we have this. So therefore, what it means that this reaction is high molecularity. So if you have two reactants that are participating in the reaction is called bimolecularity. And if it is only one reactant, for example, two reactant, let's say you have two reactant, let's say you have P, A plus B, produce your product or to generate your product. So you see, you have two reactants, so it is bimolecularity. But if you have A, just you have your product, one reactant with one, give you your products, then it means that that one is unimolecularity. But in a situation where you have A plus B plus C to have your product, and this described as molecularity. It described as molecularity. So since in this reaction we only have the acetate or the acetate or the acetic the ethyl acetate, only have ethyl acetate, and water is considered as a medium because increasing and decreasing the concentration of water will not affect the rate of the reaction. So that is why it is first order. And then of course you have two of the reactant. You use water and then ethyl acetate. So that is why it is bimolecularity. So it means that in these questions, the answer is A. So then we are now going to look at the next question. We are now going to look at the next question. So in the next question, it's also similar. It's also on direct. So let's look at what we are going to have. So in the next question, is a calculation where the question says calculate the rate constant by a hypothetical reaction between reactant A and B. So if the order of the reaction with respect to each reactant is 1 mole and their respective concentration given as 2 molar and 8 molar respectively, where the rate of the reaction is given as. So first, in this case, we are going to start with driving the, we have to drive the, first we have to actually bring out the data. So we have two reactant A and B. So therefore, the reactant A here has a concentration of 2 molar, and then the reaction B here has a concentration of 4 molar. So, and of course, from the questions, we know that we have to start with the rates. It's equal to K times concentration of A. And of course, each of them have an order of the reaction of 1 mole. So it means that the order of reaction of A is 1, and then times the B, and the order of B is 1. So it means that first is A is a first order, B is a first order, and the overall order of the reaction is 2. If you take 1 plus 1, then it's going to give us 2. So that is why it is a second order reaction. So, and of course, where the rate of the reaction is given, so the rate is given as 8. The rate is given as 8. So now what are we going to do? We are to calculate the rate constant. So therefore, how are we going to calculate our rate constant? So we have our rates. So we have 8 here, and then K is unknown, and then we have our E. So our E is 2, and then our B is 4. So we are now going to have 2 times 4, we have 8. So therefore we have 8 is equal to K8. So divide both sides by 8. By 8, this one cancel this. So we have X is equal to 1. So we have K is equal to 1. And then what is the unit? Although all the option is only this one that have 1, so it means that the answer is B. But you should understand that this equation is a second order reaction. So you know that first order reaction have their K, has their SI unit for K, that is the rate constant. Pseudo order reaction has its own unit, second order and third order. So based on the order of the reaction, we can actually know the SI units of our rate constant. So ladies and gentlemen, so this is the end of this video. So we are going to meet in the next other videos. Thank you.